next one is y equals to sine x. Now x is a continuous random variable with CDF. So we know the CDF. Okay, we were not given explicitly a CDF function, but we're just telling you that is fx. That is a CDF function for x. Now, what is a CDF function for sine x? So sine x is actually a function of x. What is a CDF function for sine x? So f y given under y. Still, let's write down the CDF function. This equals to, because let's put the sine x into this equation. Okay. Now, still we have several cases. Case 1. So if you are taking the sign of a random variable, okay, then what is the range of sine x? Sine x, the range is -1 to 1 because sine, right? No matter what x you have, the sine is actually oscillate between -1 to 1. So for case 1, what if this y less than -1? So if for this case, this y equals to what? 0. Because sine x could not be less than -1. Okay? Second case, -1 y and less than 1. So this one we need to find out. And the third case, case 3, y greater than 1. Then what is y? What is the value? If y greater than 1.
1.
If y greater than 1, then sine x less than, suppose y equals to 2. Okay? What is the probability sine x less than 2?
1.
And if y any value greater than 1, then this should be 1, right?
Yeah.
So now the problem is we need to find out this case 2. So case 2 is our real problem. Now let's figure out how to get the case 2. For -1 less than y less than 1. So let's see, okay? So let's first draw the sine wave. So this is the sine wave. This is x. And this is the y. So let's draw the sine. Hopefully I draw it good. Okay, and we have sine on this side. Okay, so for the sine wave, we have 0 here, and what is this location? Pi, and what is this location? So we have 2 pi here, and a pi here. And suppose we have some kind of y. Suppose this is x, this is y. Now we have this is actually 1. Now suppose we have 1/2 here. And if you draw the 1/2 line, and you are going to have this one, right? So what is this one? What is this location of 1/2? Sine for sine Hmm?
So 30 degrees.
30, right? So 30, you should have 30 here, then pi minus 30. This should be this location. What is this location? 5 pi over 6, right? And this is pi. This is 2 pi. And what is this location? This location should be 2 pi plus pi over 6.
Which is
Right? Yeah. So now let's, so far, then for all the y less than, it's over here. Right? Less than this 1/2. But this is continuous. If you extend, you will have another one over here, right? Okay. So f y equals to probability capital Y less than lowercase y. This equals to probability sine x less than or equals to lowercase y. This lowercase y actually denotes a specific value between -1 and 1. So this is actually equals to the summation n from -infinity to infinity. So probability, we have 2n plus 1 pi minus sine inverse y less than equals to x, and then less than or equals to 2n plus 2 pi plus sine inverse y. So if we try to get this, this is actually n from -infinity to infinity, because we were given this CDF function. So this will equals to f capital X. Actually, what is the CDF function here? 2n plus 2 pi plus sine inverse y minus fx 2n plus 1 pi minus sine inverse y. So we got this CDF function for y. So when it is less than 1, this is 0. Greater than 1, this is 1, because everything is less than 1. Okay? In the middle, we need to find out the x, because this is y, and we find the x in this range, it will be less than this y, right? Y is less than this y. So the x should be between pi, so this is if n equals to 0, so it should be pi minus this sine inverse y. And then this is 2 pi plus sine inverse y. And this can, because sine is a periodic function, so you need to add the next cycle and then the next cycle. So you add all of them together, so this will become the CDF function for y. Am I making sense? So this is transformation of distribution. Obviously, the key here is first we need to find out what is the function, y and x. What is y is a function of x. We need to find out what is the function. So here is sine. Previous one is x squared. And then we need to transform, because we need to find CDF, y less than or equal to y. Then we need to put this x in. And then we need to find out what is the range of x. And then based on the x, and because we know the CDF or the PDF of x, and we will be able to derive the function for y. Derive the CDF function for y.